Okay, so in this video, we're going to talk about units. All right, and so units, when we're talking about units, it's basically an important fundamental mode of how we communicate the meaning of numbers, right? Numbers are not useful without units. Units, they define quantity used as a standard of measurement. So, like for example, in everyday language, as I said, we use units. Like for example, if I have six what? What do you mean by six? And so without a unit, you cannot put anything into context in regards to the number six. Do I have six dogs? Do I have six cats? Do I have six pairs of shoes? Stuff like that. So, these are all units, okay? Because it defines or it gives context to the number and it helps us to communicate these things back and forth. Now, when it comes to science, there are different physical quantities that we tend to measure, and these physical quantities are oftentimes are related with units of itself. And so what do I mean by that? The different physical quantities that we tend to measure, we have things like length, volume, mass, okay? So we oftentimes measure these things and they come with units. So length, we have like inches, feet, centimeters, furlongs. Volume, we have gallons, we have centimeters cubed, liters. For mass, grams, pounds. So all these are units to describe these physical quantities that we tend to measure. Now, the global scientific community agreed to a set of units which we call the SI units. The SI units are closely related to the metric system that is pretty much used everywhere else in the world but the US. Okay, and so just kind of talk about this very quickly, where we have the measurement of length is usually measured in meters. Mass is in kilograms. Volume is in cubic meters. Temperature, Kelvin. Time, seconds. Electric current, ampere. And then the amount of substance is mole. So now, in terms of mass, and weight, in the vernacular language, it's often used interchangeably, but in science, they have very, very different meanings, okay? So mass is a measurement of amount of matter that's in an object. Weight is a measurement of amount of gravitational pull that a large body, such as a planet and moons, exert on an object. So the amount of matter of the object is completely independent of its location. So it doesn't really matter exactly where it may be in the universe. The mass of that particular substance will remain the same. Okay. So the SI unit for mass is kilograms. Okay. And which is roughly about 2.205 pounds, in the United States. And then in chemistry and medicine, kilograms is way too large of a unit. So oftentimes we use just grams or milligrams. So like for example, you'll find that many over-the-counter drugs, when you look at the bottles, the active ingredient is always in milligrams, okay? The SI unit for length is meters. And then meter is roughly about 39.37 inches, a little bit more than a yard, right? But in chemistry and medicine, once again, usually meters is often too large of a unit. So smaller units such as millimeters are often used, or centimeters. Like in countries outside the US, it typically a person's height is measured in centimeters. Now, the SI unit for volume is cubic meters. Okay, and cubic meters is roughly about 264.2 liters. And once again, in chemistry, medicinal purposes, usually cubic meters is way too large of a unit in many, many experiments. And so you'll find that liters is oftentimes used. Centimeters cubed or cubic centimeters is used. Millimeters is often used as well. And so These are typically the type of units that's used in these applications. So one of the advantages of using the SI units is that all the denominations of the units are all related by the powers of 10. And this proves to be very useful, as many physical quantities that exist in the natural observable universe are either very, very large or very, very small, especially that each power of 10 is oftentimes given a very specific prefix. Okay. So, for example, if you're talking, you have just your base, which is usually a base of 10. Then if you look here, right, the prefix deca, it's typically times 10 to the first power of your base unit. And I'm going to give you a couple of examples. So, but just kind of follow along with me. Kilo is often used a lot. All right, so here's that symbol, and it's 10 to the third. Okay, so this simply means that there's 1,000 of the base units in 1 kilo. Okay. Same thing with giga, times 10 to the ninth, and that means there are 1 billion of the base units in 1 giga. Okay. While you have, if you go the opposite direction, you have milli, 10 to the negative 3. All right. And so for every 1 unit of your base unit, there's 0.00, or every 1 milli, I apologize, for every 1 milli of that unit, there is 0.001 of that base unit. Okay. And so, why is this really, really important? All right, so like, for example, just kind of keep it within the times. You have the current COVID-19 virus, right? And then when it comes to the length, the COVID-19 virus is, I accidentally used a highlighter, is 0.0000009 meters in length. All right, that's how long it is. I mean, and so if you're seeing a number like this, it's obvious to see that meters is a very inconvenient unit in this case. All right, because it's just the way how this number is laid out. Or another example, like if you're talking about the distance between the sun and the earth, the distance between is 150, 3 zeros, another set of 3 zeros, another set of 3 zeros meters. And that's the distance away from each other. So, looking at a number that is this small or that is this large, oftentimes it seems really, really confusing. So instead of using these units for these extreme circumstances here, as of the size of a virus or the distance between the sun and the earth, we could change the units. And so that way the numbers are just a little bit easier to comprehend, right? And we use these prefixes to kind of help us out on that. All right, so let's just kind of show you some examples of able to convert from one unit to the next. Okay, and so like, for example, let's just say, you measured something that was like a table. Let's say you measured a table, and the table turned out to be about 1.50 meters long, right? And let's say you just want to know, okay, if it's 1.50 meters, how many centimeters is that? Okay. Remember, meters is our base unit. Okay, so when we're looking at this, we see centimeters, and for every 1 base unit is 0.01 centimeters. Okay, and another way you can kind of look at it is that if you see your exponent here, that number tells you how many times you can move the decimal, all right, from the base unit. Okay. And the sign could kind of give you an idea which direction. All right, so if it's 1.50 meters of your base unit, okay, we can move it over twice, okay, and it's going to give us how many meters, 1.50 meters in centimeters. And so in this case, it's 150 centimeters, okay? And the same idea with if you're going from let's say you measure the mass of a particular object, and the mass of that particular object turned out to be 361. Let's go big. Let's go kilograms. Okay, and I want to know how many grams is that particular object. So if you notice, right, if you look at kilograms, so kilograms, there is 1,000 grams in 1 kilogram. Okay, this kind of could give you an idea how many times you need to move that decimal. And so you need to find the decimal first. Once you find the decimal, then you can move it that many times, so that it could be in grams. In this case, we're going to move it towards the right. All right, and so 361, here's your decimal, 1, 2, 3. We moved it 3 times. Here's our new placement of the decimal. And so any empty spots, we add zeros. So in this case, the answer would be, all right, 361,000 grams. All right. Now, this is kind of like a little mnemonic you could use to help you memorize this per se. I mean, you guys are going to have to make sure you know this practically by heart. But what I typically know to help you memorize this is really only going from kilo all the way down to milli. So I don't know if this is really going to help out so much. But, I mean, anything helps, right? So, you have kilo H. All right, so kilo hecto. This is your deca. Base, this is your base unit. Deci, centi, and milli. All right, and the way I remember this is King Henry died by drinking chocolate milk. All right, so that's your kilo, hecto, deca, base, deci, centi, milli, and then you just guys gonna have to memorize the units. That's kind of outside of it, but and the cool thing about this, it's like it's a cool visual aid to help you envision how many times you could move a decimal back and forth, and which direction you need to move in, and where, and how many zeros you need to move here and there. So like for example, let me kind of give a hard one, and you can kind of see where I'm coming from. So let's just say you measured a volume that's 15.0 centiliters, okay? And I want to know what's that in hectoliters. Here's my decimal, okay? So we're starting here at the centi portion, all right? And I'm going to end here at the hecto portion, all right? And so now when you kind of look at this, it's okay, how many spaces or how many times do I have to move to get from centi to hecto, right? And so when you're looking at it, it's like, oh, well, 1, 2, 3, 4. So that means my decimal is going to move 4 times. Now, if you paid attention, what direction did I move? Well, I moved to the left. Okay, so I'm going to take my decimal place here. I'm going to move 4 times to the left. 1, 2, 3, 4. All right, and so all my little valleys here, I'm just going to make it zeros. All right, and so that means that 15.0 centiliters is 0.00150 hectoliters. And that's a way that you could kind of do this, all right? Let's go through one more example for the sake of just going through one more example. Let's just say that we measured the mass of something, and it turned out to be 100. Let's go bigger. Let's say 1,683.2 kilograms, and I want to know what's that in milligrams. Like, what is that in milligrams? All right, well, let's get started. So we're starting from kilograms, and I'm ending in milligrams. So how many jumps does it take, or in which direction? And if you notice, it's going 1, 2, 3, 4, 5, 6. So we moved 6 times to get to milli. All right. And now what direction did we move? Well, we move towards the right. So I'm going to take my decimal place here. All right. My decimal place is here. It says 1,683.2 here. And I'm going to move it 6 times to the right. 1, 2, 3, 4, 5, 6. And here's my new decimal place. And I'm going to add all these zeros here. So that means that this in 1,683.2 kilograms is 8, 3, 2, 1, 2, 3, 4, 5. So that way, okay, cool. So it's that many milligrams, all right? So it's a pretty big number. So that's how we could use this table here in our benefit. All right, so that way we could change the prefix, and that way it could change that number and make that number, or the magnitude of the unit, a little bit more easier to comprehend. All right, now another way that you will find that scientists will change numbers is going back and forth from scientific notation. All right, and so, like, for example, when I gave you the example about the distance between the sun and the earth, we said it was this many meters. Okay, now this is a very large number, and oftentimes numbers this large, it's just a little bit harder to comprehend. All right, so but we could change these numbers to scientific notation, and so that way we're using a much smaller number, but we're keeping the value of that number the same. Okay, and so how do we do that? Much like converting from different prefixes, one of the first things that you want to do is that you need to be aware where is your decimal. So in this case, the decimal's here at the very end of the number. Okay, now you want to move the decimal to where that it is to the left of the very first non-zero digit. Okay, and in this case, the very first non-zero digit is this one here. So I'm going to move my decimal, all right, until it's to the left of the non-zero digit is to the left of the decimal. Okay, I want to make sure I don't confuse you guys. So let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I moved this 11 times, and you notice I moved it towards the left. Okay, so when I rewrite this number, I'm going to write 1.50 times 10. So you always write times 10. Now we moved it 11 times. Now, but depending on which direction you moved it, depends on what's the sign of the exponent. When you move it towards the left, all right, when you're writing a standard number notation to a scientific notation, when you move the decimal to the left, the number, the exponent will be positive. If you move the number towards the right, the exponent's going to be negative. So in this case, it's now 1.50 times 10 to the positive, and I'm not going to put a plus sign, but to the positive 11 meters. Okay, and so that's the number for that one, right? And when we was talking about the size of the COVID-19 virus, right, we said that initially it was 0.000000009 meters. All right, and so once again, I'm gonna move my decimal to the right. All right, so that way the first non-zero number, which is 9 here, is to the left of that decimal. So let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it's here. And so when I rewrite this, it is 9.0 times 10. How many times we moved it? We moved it 1, 2, 3, 4, 5, 6, 7, 8. We moved it 9 times. Since we moved it towards the right, like I mentioned earlier, all right, we're going to give it a negative, the exponent a negative number. All right, and so in this case is negative 9 meters. All right, and so that's basically how you convert a number from standard notation to scientific notation.